Hi, welcome to our lesson, Part 2, Trigonometric Ratios. In this lesson, we're going to be looking for missing angles. In our last lesson, we were finding the length of sides. And we had an acronym. If you stub your toe, you soak a toa, correct? Soak a toa is an acronym that you can remember easily, and what it should tell you is this. The sine of an angle is always equal to, now we're talking about in a right triangle, the sine of an angle is equal to the length of the opposite side divided by the length of the hypotenuse. So it's kind of up to you to remember that we're talking about the sine of the angle and the length of those sides, opposite and hypotenuse. Because typically then we will abbreviate this acronym to say the cosine equals the adjacent over hypotenuse. And then we might even abbreviate it to say tangent equals opposite over adjacent. So we'll do a lot of abbreviations with those. It's up to you to fill in this information here, the of an angle and the length of. Always make sure you understand that we're talking about the length of the opposite and adjacent and hypotenuse and the tangent of the angle. Okay? And remember on your calculator, when you are trying to find the tangent, cosine, or sine of an angle, there we go. So if I need to find the sine of an angle, I would push the sine button. And then what angle am I looking for the sine of? So key in the angle. And so the sine of 37 is 0.60. Now, this lesson, we're going to do this backward. We're going to put this whole thing in reverse. For instance, if I know that the tangent of some angle equals 0.84, how will I find x? Well, that is the inverse operation. And the way we write that is the tangent of, inverse tangent of 0.84 equals x. And there is a -1, meaning inverse function, right above the tangent. That is on your calculator. So if you don't know the angle, but you know what the tangent, sine, or cosine of the angle should be, you can use the inverse function to find this. For instance, in the one that we just did on our calculator, the inverse sine of 0.61 should be very close to 37. Let's try that and see if it really works. So if the sine of 37 degrees is 0.61, the inverse sine, or the opposite function of 0.61 should give us 37. Let's figure that out. So second function, to get the green or the second level functions of the buttons, sine, you see now we have the inverse. Let's put in our 0.61, and we estimated, so we won't get exactly 37, we will get something very close, and we did. Now if we put in the inverse sine of 0.6018, that's a little bit better of an estimate. 0.6018, let's just go farther, 1815. That should give us an answer a lot closer to 37, and it did. So when you estimate that, the farther out you can take your decimal place, the closer your answer will be. Now, the example we were just looking at in our discussion was, what if we need to find the inverse tangent of 0.84? Well, let's just put that in and see what it is. Inverse tangent. We don't know the angle. We're trying to find the angle, not the side length. So that's when we're going to use the inverse function. So second, inverse tangent of 0.84. And that is an angle of about 40 degrees. So in our last lesson, we were looking for the, in our last lesson, we were looking for side length. So we were using those ratios. In this lesson, we're going to be looking for angle. For example, if we have a triangle remember, these are all right triangles that we're referring to. It only works on right triangles. So we'll have our 90-degree marking in these triangles. And let's say we are trying to find this angle right here. And what we know is the side length of the triangle. So we have an 85 for the hypotenuse. We have a 51. And we have a 68. And we need to find x. Now, the confusing part of this is there are three possibilities that you could use. All three would give you the same exact answer. If we want to use the sine function, the sine of x is going to equal opposite over hypotenuse. So the opposite side of x is 51 divided by 85. Remember, when you're trying to find the opposite, you bring your pointer to the vertex of the angle and you go straight out across the middle. That is your opposite side. It's easy to find the hypotenuse, and the adjacent is the other one that's right next to the angle. So the 51 is our opposite side. Now, if we wanted to use the cosine function, cosine of x equals adjacent over hypotenuse. That would be 68 over 85. And if we wanted to use the tangent function, because there are going to be situations where you have to choose one based on the information given. If they don't give you the hypotenuse, for example, you can only use opposite over adjacent. That is sometimes what makes it confusing to use these trigonometric ratios, because sometimes there's more than one way to get the answer. So we could use any of these three and get exactly the same answer. So we could use the sine of x equals 51 over 85. And let's do that now. The sine of x is 51 over 85. So let's go to our calculator. And what we know is the sine of x is 51 over 85. Well, what is 51 over 85 exactly? So 51 divided by 85 is 0.6. So the sine of x equals 0.6. Therefore, the inverse sine of 0.6 equals x. So 36.86, around 37 degrees. When we use the sine function, it gave us 37 degrees. Pretty close to it, because we did 51 divided by 85 is 0.6. Let me actually make that a little clearer. So the inverse sine of 0.6 would equal x, which is 37 degrees. A little more clear on that one. So the cosine of x, if we're going to use that function, we must figure out what exactly is 68 over 85. Let's go to our calculator and figure out what 68 over 85 is. And I'm going to do it a little differently on this one because I want you to use that function. We're going to do our n over d function, put a fraction in, 68, directional pad down, 85, put that fraction in, and directional pad to the right to get out of your fraction, push enter, and it will simplify the fraction for you. And remember, we have a button to switch the format, the old switcheroozy button. 4/5 is 0.8. So if 68 over 85 equals 0.8, then the inverse cosine of 0.8 should equal x. And remember, we have inverse, so we'll have our -1 right there. So the inverse cosine of 0.8 should equal x. Let's see and make sure that that is what happened. Inverse cosine of 0.8 sine inverse cosine 0.8 parentheses enter 37 degrees. We get the exact same answer. And again, let me say that is sometimes what is confusing with trigonometric ratios because there's more than one possibility of how to do these. So if we do the inverse tangent of 51 over 68, we should also get 37 degrees. Let's do that. Inverse tangent of 51 over 68. Now in the previous two examples, I found the decimal first. But what if we just put the fraction in? So inverse tangent n over d, 51, down on your directional pad over 68, arrow to the right on your directional pad, close that parenthesis up, and now we're going to save a step. So instead of converting this fraction to a decimal first, let's just put the fraction in and find the inverse tangent and see if that works. And lo and behold, it does. 37 degrees. So it makes no difference how you do it. You could actually put this whole fraction inside of those parentheses, and you're still going to get the same answer, which is 37 degrees. Now, this worksheet that you are about to do is doing exactly this. You're not going to really be using sine, cosine, and tangent on this one, but more the inverse cosine, inverse tangent, and inverse sine, using the same ratio. It is up to you on the problems to figure out which one you need to use. For example, on number 30, So on number 30, you're given a right triangle. And it's situated a little differently, like so. And they only give you, let's see, you're looking for this angle right here. And they give you 44 and 135. This is number 30 on your worksheet. They don't give you the length of your hypotenuse. So what is the opposite side? Always start at your vertex of the angle in which you're trying to find. Go straight across the middle. There's the opposite. So you have the opposite side and the adjacent side. Which trigonometric ratio are you going to be able to use when all you know is opposite and adjacent? Well, you're going to have to use the tangent function. The tangent of x is going to equal the ratio of the opposite side to the adjacent side. So 135 over 44. You will not be able to use the sine function because you do not know the hypotenuse. You don't have the h. So you also cannot use the cosine function in number 30 because you're limited on the information that they've given you. You can't use these. You have to use tangent because all you have is the opposite side length and the adjacent side length in relation to the angle that you are trying to find, which is your x. Okay? All right. Good luck, and I will see you in the next lesson.